dense than air. And when gases are less dense than air, they're going to float in air. And we can see that these balloons, they're floating in the air. If I let this go, it'll continue to float and continue on up into the atmosphere. That's why we have it tied down. Now, you are probably used to seeing balloons that do this. The balloons that you normally hold are filled with a gas called helium. And the balloons that you use are filled with helium because helium doesn't react with anything. It just stays the way that it is. So you can actually breathe it in, as long as that's not the only thing you're breathing in for a long time. But you can breathe it in and it's not going to hurt you. This particular gas is different than helium. Let's see how this gas is different from helium. What I'm going to do is I'm going to take a wooden splint here and I'm going to light it on fire. And I'm going to hold that lit splint to the balloon and we'll see what happens. Again, this wouldn't happen to a balloon that you're used to. This balloon is filled with what's called hydrogen gas. And hydrogen gas reacts with oxygen in the atmosphere. Let's see what that reaction looks like. Than the gas that's put in the balloons that you usually carry. They're not going to want to put hydrogen gas in the balloons that you get from the grocery store. That could be a problem, couldn't it? Yeah. Hydrogen gas reacts explosively with oxygen gas and it produces a lot of energy. And hydrogen gas is actually a type of fuel that people are studying to power cars and other types of sorts of things so that we don't have to be so dependent on gasoline and fossil fuels. Would you like to see that again? I think maybe Daisy should do the other one. What do you guys think? Yeah? All right. Let's see if she can do this. There you go. Now she's a freshman. Let's see. I put helium in the balloon. Whoa! That's not helium, is it? Well, that's hydrogen gas. And hydrogen gas, it reacts explosively with oxygen gas that's in the air. And what it actually produces is water. That's what ends up being the product of the reaction. It's just water. And sometimes they call hydrogen a clean fuel because of that. Because when you burn hydrogen and oxygen, you get water. Well, Daisy and I, we like to compete in the lab. Now, if you look at Daisy's coat, you might imagine that she likes color a lot. Yeah? It's a kind of colorful coat, isn't it? Like a rainbow on that last coat. Kind of like Dr. Baldwin's there in the back. Dr. Baldwin is my colleague. He also teaches chemistry here at Spring Arbor University. And for me, I'm a little bit more of a, well, you might say, an evil scientist. I don't like color. I like to get color out of stuff. So Daisy and I might have a little competition when we go into the lab. I see these colors, and I don't like what I see. I just want to take those colors, and I want to just make them disappear. Bah humbug. So take that, Daisy.
Take that. I see these. Colorless empty beakers. And aren't they just sad? Those aren't fun at all. They're not festive or colorful. Right? This is
I gotta fix this. I don't want that. I don't want that.
And nobody likes these over here. Working a little bit faster.
Ah!
What do you think?
Oh, she certainly is.
Come on, you're too fast for me. I can't keep up.
Wow, so skillful. Amazing. Uh-oh. Oh, is it going away on this side now? Yeah. Are we sad or happy?
Come on! What's going on here? Oh, she's gonna get it all colored up. I don't want it to be colored.
Disappears and reappears.
I'm having trouble here. That was hard to change. I'm having
I'll
trouble.
project. I think I can do it. How many times can they do this? Just
We'll
three.
have to find out.
There we go. There we go.
He just keeps doing it. Wow.
You know, I think I have an idea. Come here. I think I do have an idea.
No.
Let's try it. Let's try it.
We'll give it a shot.
You know, you're going to have to change those back.
You know that's not my forte.
Well, I tell you what. How about you?
Without that base.
That's right. That's
Not that
right.
base. No acid.
Why don't you use this,
Okay.
and then I'll make you go back to color.
Okay.
All right, let's do that. That's fair. That's fair. And then you can do that over there. Let's do that. That'll work. My job,
Guess that's the way to succeed.
take the color out. There we go. Uh-oh. Gotta refuel.
There must be something secret behind that board. What do you think?
Maybe?
Maybe.
Maybe. Science.
Wow.
Uh-oh, not great almost, huh?
Nothing's happening. Is it done?
A little bit of yellow in there. Do you see it? A little bit.
Just a little.
Not as good as the others. A little bit of yellow in there. No, yeah. Who sees it? Anyone see it? It's on half of you. Okay. Maybe some of you are colorblind. It happens. It really does. Some people find out they're colorblind at these shows. Oh, that one worked much better. Yeah, there we go. Yeah. All right. So we can agree on this. I think that'll work. I think that'll work too. So how do you think we did this experiment? Would you like to learn how? Yeah, okay. Let's learn how this experiment is done. This experiment is done using what are called acids, bases, and indicators. You see, an indicator is a chemical, it's a dye, that will change color depending upon whether it's in an acid or a base. If an indicator, and the indicators I'm using here, those indicators, they're all colorless in an acid. They're colorless in an acid. So I was always using a chemical called an acid. And when I would go through, there was a little bit of acid soaked in the sponge that I was using. And when I would swirl the flask, the contents of the flask, which with the sponge, the acid would go into the water in here that contains an indicator. And the indicator would turn colorless in an acid. All the indicators here, they're all colorless in an acid. So I add acid, and the indicators go colorless. Daisy, on the other hand, would add base. And bases and acids react with one another. So when Daisy would add a base, the base would first react with the acid and neutralize it. And then once the acid was neutralized, as base was continued to be added, the solution would become basic. And then when the solution would become basic, all of these indicators turn colored in a base. And they're different indicators in each different flask. And this one over here happens to be purple, violet in a base. This one happens to be blue in a base. This one happens to be green in a base. This one's yellow in a base. This one's orange in a base. And this one is red in a base. You see that on both of these. And I'm going to do some experiments again later to show how this sort of works. Now, how do we get yellow at the end? This is a bit more complicated, but acids and bases are rated with something called pH. Have you ever heard of the pH of a system? The pH, it's a measure of how acidic or basic something is. And what's interesting about all these indicators is at a pH of 9, which is basic, they turn yellow. Above pH 9, which means they're getting more and more and more basic, then they turn to the reds and the oranges and the yellows and well, of course, the green and the blue and the violet. So with the pH scale, 7 is neutral, that's like water. Below 7 is an acid. Above 7 is a base. The higher above 7 you get, the stronger the base. The lower below 7 you get, the stronger the acid. So let's show you some more experiments that we can do with this. With indicators, they're really neat dyes that can change color depending upon whether they're in an acid or a base. And now I'm going to sort of let you see how the experiment's set up. Right down here. Okay. Here I have some bottles, and in each bottle is a different indicator that will turn a different color in the base. This one's orange. I'm going to add 3 drops of orange here. And Daisy, why don't you add about 200 mils of base to that? And when she adds base to that, we should see a color, because all of these indicators turn color in a base. Here's yellow. Red, orange, yellow. Yeah, put one more. Yeah.
What color is it?
It's colorless. I didn't add indicator to that one yet. There's red. Let's add red over here. I'm going to add the indicator. This is a red indicator in a base. And you can see it. These last 3 have not had the indicator added yet, so we're not going to see any color. Not until I add it. There's violet. I'll add that to the last one. There we go. There's green. This one's green in a base.
You.
And this one is our blue. Different indicators can give you different colors in a base. How much fluid do we have? I think we got enough. Let's add a bit more. I'm adding base now, okay? I'm adding base. Just so you know. going to do is we're going to add a little bit of dry ice to each flask. Okay? Anybody know what dry ice is? Okay, you've seen that stuff before? Dry ice is made of carbon dioxide. And when we throw the dry ice into these flasks, that carbon dioxide is going to bubble through the solution. And some of that carbon dioxide, a lot of it will escape, but some of it will dissolve in the fluid. Let's watch what happens when we put dry ice into these different solutions. We got some over here. Add a few drops. Add some here. Daisy. So again, I'm adding dry ice, which is carbon dioxide, to each of these flasks here. We're going to see what happens. Let's put one in there. Get a little bit of a fog, don't we? A little bit of a cloud. Anyone ever use this stuff at Halloween? Yeah? Use some dry ice at Halloween? Oh, that's beautiful. That just makes my heart sing. Look at that gorgeous chemistry going on. Yeah. You notice something? The pH is being lowered. In these three flasks, I can tell that the pH is at least 9. Because when it gets down to a pH of 9, the indicators all turn a little bit yellow. And if that continues to bubble through, we might be able to get it to go colorless, because carbon dioxide, when it dissolves in water, is an acid. We are making acidic solutions here, and the dry ice is the carbon dioxide. When it goes into the water, it's first neutralizing the base, and then it makes the solution slightly acidic. Looks like it's taking a little while on these. Those are still at pH 9. That one finally looks like it might be colorless. But we can reverse this process very easily by adding base. That's right. Let's add some base. Get the color back. Go for it. We'll let Daisy do this. Go for it. Change the color act. Again, these indicators, they all turn color in base, and they go colorless in an acid. And chemists use this all the time to see what's going on. It helps us kind of see what's going on in chemical reactions. Mr. Bear. Mr. Bear.
Where's Mr. Bear?
Time for Mr. Bear.
Where is he?
I don't know.
Does anybody know where Mr. Bear is? Not like bear. Not that kind of bear. Bear aspirin.
Let's have a hand for Daisy. Is Mr. Bear ready? Okay. He's back here. Mr. Bear, we're ready for you.
Yes.
We're ready for Mr. Bear.
All right, thank you. All right, I'll project. Hopefully, if you can't hear me in the back, raise your hand. Okay, you wouldn't have done it. You wouldn't have known anyhow. Okay, so anyhow, welcome to Halloween in the science lab. Well, we're not in the science lab right now, but soon enough we will be. And what's going to happen is if you join me over in room 103, room 103, I have some guests. And in there, the first thing you're going to do when you walk in is I want you to get a pump of hand sanitizer. Just one pump, go like this, dry that out. What that's going to do is that's going to mask any scents that you may have. It's going to cover your smell. Because in there we have some hissing cockroaches, which they're great because you pick them up and they get a little, woo! You might drop them right there in the tank. That's okay because that's where they belong. We also have some blue death feigning beetles. So when you pick them up, they feign death. they pretend they're dead. They just, and then later on, you poke them and they wake up and they run along. And then we also have a tarantula that we can definitely look at. You can reach in, you can touch, but we're not going to pick up the tarantula because tarantulas are venomous. I mean, they have venom. So we're going to be super careful around that. But we also have some other animals that you can hold. One is, this is Checkers. Checkers is a Miami corn snake. And now, this is where accidents happen, and I'm going to tell you right now, is that you'll notice with Brendan, he's not putting the snake around his neck. Because if he puts the snake around its neck, it's going to get comfortable right there, but then it's going to go into a defensive posture. And then when you reach in and go, oh, hi, snaky, snaky, wham! That's when it happens. Now, these are not venomous. These are constrictors. So the worst they can do is make a little bite. Oh, wait, I said bite. Well, do these snakes have teeth? Yes. Both of these snakes have teeth. Both of these snakes bite. Now, I'll tell you when they bite. They will bite. Is anyone in here a rat? If you're dressed as a... No, I'm just kidding. If anyone is a rat or a mouse, you're food. And guess what? Neither one of these snakes eat kids or adults. So don't worry about it. They don't want to eat you guys. Oh, but there's a couple other reasons they can bite you. They can bite you if you hurt them. Look, I'm not wrestling on, crikey, I got him. No, I'm not grabbing him by his neck. He's holding on to me, I'm holding on to him. It's a little bit of respect right here. I know, respect with the snake, that kind of sounds odd. But it happens so that we are both comfortable. Also, the third reason is if I scare it. So if I make a sudden movement, or I jerk, or I yell, or I scream, that could scare the snake. But right now, you'll notice we're not doing that. Makita's fine, and Checkers is fine. So please, come over, visit us at 103. As you leave, also get another pump of hand sanitizer so that if they have any germs or anything like that, we're going to make sure that everyone still stays healthy and safe. So I'll see you guys over in room 103. I'll turn it back over. You guys sit. Okay.
Okay, guys, thanks for coming to this portion of Halloween in the Science Lab. At this time, we're going to ask you to move over to the Lightning Gibbs Science Center. Please, if you can, consider donating a few dollars to the event. We spend a lot of money on candy for the kids. If this is something that you'd like to do every year, consider giving us a few dollars so we can continue to hold this event. This will be in the main office. Thanks, you guys. See you over next door at the Lightning Gibbs Science Center.